Alrighty, we have this video lesson here on the identity matrix and the inverse matrix. We're going to talk more about the inverse matrix. The identity matrix is this idea here. The identity matrix is a matrix, and we use the capital I to identify that it's the identity matrix. And when we're talking about the identity matrix, it's for a 2 by 2. This main diagonal down through here will have ones in it, and every other number will have a 0. Now, if we look at a 3 by 3 matrix, the identity for it, the main diagonal, will all have ones, and then everything else has zeros. And you can only imagine that for a 4 by 4, that it would look something similar to this. If you imagine these not there. So that's the identity matrix. And the whole goal is, like say, if we have matrix A and we are going to multiply it by the inverse of matrix A, which you're going to learn what the inverse is on the next slide, learn how to find it. So if we take matrix A, we multiply it by the inverse of matrix A, we will get the identity matrix. So I just want to give you a quick heads up on what the identity matrix looked like. And so now here will be kind of the definition of the inverse of matrix A. So just pay attention here. If you want to write this down, you can pause the video when I'm done, and then you can go from there. It says the inverse of matrix A, and if we notice, this is matrix A. So the inverse of matrix A is this, and we notate it with raised to the -1 power. Because if you notice, remember from your algebra class, when you have a negative power, you take the inverse of it. All right, so if we look here, on the left here, you have a fraction. So this is a fraction. And it is 1 over top of, and remember, that is the determinant of A. So you find the determinant of A. And once you find that fraction there, 1 over the determinant of A, you are going to multiply it by this matrix here. And if you notice, some things have switched. B and A. Look at their position from the original matrix A. Those have just switched places. But B and C stay in the same place, with the exception they get a negative sign with them. So that would be negative B and negative C. So if you kind of remember it like that, these two positions trade, and these two positions become opposite, or negative. Opposite, I like opposite better, because if one of them was negative already, then it would become a positive. And then out here at the very end it says, provided that A times D minus C times B does not equal 0, and A times D minus C times B is how you calculate the determinant of A. And we cannot have 0 on the bottom of a fraction. Okay, let's move on. Let's give you a chance here to find the inverse matrix of what's given. Okay, so basically, remember, so inverse matrix, so the inverse of A is equal to 1 over the determinant. So we'll say 2 times 3, which is 6, minus 1 times 2, which is 2. 6 times 2 is, or I'm sorry, 6 minus 2 is 4. So that's what we have here. 4 is the determinant of A, and that's why it's down here on the bottom. And so now, this matrix that we're looking at, the two that I've circled up there, they trade positions, and then the two that's left over become opposites. And so that's where we're at. Next step is to do the scalar multiplication. Multiply 1/4 times everything inside. 1/4 times 3. 1/4 times -2 Make sure we always reduce fractions. 1/4 times -1, and 1/4 times 2. And so you have determined the inverse of matrix A. The inverse of matrix A. Alrighty, keep these notes because you're going to need these notes for the next slide. I'll need them for the next slide. Let me go ahead and copy this here. That way, when I go to the next slide, I can use it. I think, yeah. You notice how now we're solving for an unknown matrix? We have this matrix multiplied by this matrix X, and it should equal the matrix on the right. Well, how will you solve for matrix X? Well, back in the first slide, if we have, let's let this be matrix A. So we have matrix A times matrix X, and that's going to equal matrix B. Well, what do we have to, what can we multiply this left side by to cancel out matrix A and only leave us with matrix X? Well, that's the inverse of matrix A. And so if we take the inverse of matrix A, they cancel out, leaving us with X. And then if we multiplied the left side by matrix, by the inverse matrix A, we also have to multiply the right side by the inverse of matrix A. And so from there, that's how we solve it. So let's look. What is the inverse of this matrix? The inverse of this matrix, I believe we calculated on the last screen, to be, let me get that brought up here, this. Not that. All right, so now what we're going to do is we're going to take this matrix here, and multiply it by matrix B. Let me go ahead and write down that we're going to take, here's matrix A, and this is matrix X. We're going to multiply it by the inverse. That's equal to, this is matrix B, and multiply it by the inverse also. So we multiplied both sides by the inverse. And on the left side here, remember, inverse and the matrix A cancel each other out. So here's the inverse of matrix A, X, and what do we have here? 12, 2, 16, -5. And so in order to find out what X is, we just multiply those two matrices. So we're going to take 3/4, multiply it by 12, and then we add -1/2 multiplied by 16 to it. That gives us this first row, first column. We're going to also take 3/4. We get a different color here so that we can tell the difference. 3/4, multiply it by 2. We're going to add it to -1/2 multiplied by -5. And then from there, let's move on down. Now we're going to take -1/4 multiplied by 12, and we add 1/2 multiplied by 16. And now let's do the same thing for 2 and -5 here. -1/4 times 2, and 1/2 times -5. And so this is the basic outline here for solving this. Oh, 3/4 times 12. I know this can become a 1 and this will become a 3. So then that's 9. -1/2 times 16. Well, we know the answer is going to be negative, and half of 16 is 8, leaving us with a 1. So we have a 1 there. Down below, this becomes a 1, this becomes a 3. So we have -3 there. We're going to add, what's 1/2 of 16? That's 8, leaving us with -5. Not -5. 8 is larger, it should be +5. On the right here, this becomes a 1, this becomes a 2. So here we have 3 halves. We know a negative times a negative is going to give us a positive, and 1/2 times 5 is 5 halves. Add those together, that should be 8/2, which is 4. And then this becomes a 1, this becomes a 2, leaving us with -1/2. Positive times a negative is a negative, and then 1/2 of 5 is 5 halves. This should equal -6/2, which then is -3. And so now going back here, what is x equal to? X is equal to 1, 4, 5, -3. And you have just solved for the unknown matrix at the very beginning of the problem. And so therefore, if we take this matrix, multiply it by this matrix here, we should get that matrix. We're going to have one more example like this to do. I did break it down into 2 slides, just like we did the last one. You'll first find the inverse, and then we use this matrix to solve. If you feel confident, pause the video, work this out on your own. If you want to go step by step, you can, but I will be moving fairly quickly on this one. Finding the inverse matrix. So the inverse of A. So first off, it's 1 over the determinant. The determinant here is -16. And 3 times this is going to be -18, but we're supposed to subtract. So we're going to get 1/2 here. -16 plus 18 is 1/2. Or I'm sorry, -16 plus 18 is 2, leaving us with 1/2 for that fraction. Now we're supposed to trade places. For -4, trade places. And then these two numbers become opposites. This is a -3, and then -6 is a +6. So I really don't need that positive sign there. And then so let's go from here. 1/2 of -4, 1/2 of -3, 1/2 of 6, and 1/2 of 4. There's the inverse matrix. Okie dokie. And from there, let's take that. And now let's look at what we have here on the next screen. It says solve for the unknown matrix. Let me make sure that we have the same ones. 4, -6, 3, -4, 4, -6, 3, -4. Okay, so those matrices are the same. All right, so in order to cancel this one out, we want to multiply it by the inverse of it, which would then cancel them out, leaving us with x is equal to the inverse from the previous slide. Let's get that up here. The inverse from the previous slide is right here. Somehow I don't think that's all of the inverse. what number was there? -2. Put the -2 right there. And then we bring this one down. 6, 0, 5, 1. And so now let's multiply those. X is equal to, well, we're going to go -2, -2 times 6, and then 3 times 5. -2 times 6 should be -12, plus 3 times 5 is 15, should be 3. Let me just go ahead and put this right here. Now we go -2 times 0, and 3 times 1, that's also 3. And then let's look at, what are we looking at now? Let's look at a different color. So let's say -3/2 times 6. -3 times 6 would be -18/2, which is -9. And then 2 times 5, which is 10. -9 plus 10 should be +1. And then now go -3/2 times 0, which is easy to do. 2 times 1, which is 2. And so you just determined that the matrix X, in order to solve for this original equation, matrix X should be 3, 3, 1, 2. Alrighty, that's all we have for the identity matrix and the inverse matrix. If you have questions, ask me the next time you see me.